Hello friends, welcome to TEQIP GATE classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Electronics and Telecommunication Department in Government Engineering College, Bilaspur, Chhattisgarh. In this video lecture series, I am teaching Signals and System for the upcoming GATE examination. Okay, so in this video lecture series, I have completed almost 7 lectures and this is the 8th lecture in module 1, and in which this module I am teaching the basic classification of signals and systems and all. So till now I have completed many classification of signals, and in the last lecture I have completed periodic and aperiodic signal. So in this lecture we will start another classification, that is energy and power signal. So let's get started. Okay, so first we'll take energy and power signals. Okay, so what is energy signal, what is energy and signal, and what is power signal? So see, uh, which signal has some energy, finite energy. Okay, any signal, okay, any signal which is having finite energy, okay, finite energy and zero power, that signal is called as energy signal. So what we need to see, any signal which is having some finite energy in it and power is zero, that signal is called as energy signal. Okay, and for signal which is having infinite energy but finite power, this signal will be called as power signal. These two conditions you need to remember, and this, if this signal is there which is having infinite energy, okay, infinite energy and infinite power, this signal is called as neither energy signal nor power signal. Okay, so it won't be energy signal and it won't be power signal. These three conditions you need to remember while dealing with energy and power signals. So signals which is having finite energy and zero power, that is energy signal, which is having infinite energy but finite power, that is power signal, and infinite energy and infinite power, that is neither energy nor power signal. So let's take some example and understand it. So see, one question I am taking. Let's suppose one question is there. Let's suppose you have been asked ft is equal to e to the power minus at. Question is there into ut question. So you need to calculate energy. It is energy signal or power signal or whatever it may be. So see, if you plot this graph at t and amplitude, you will get to know that this signal is exponentially decaying signal. So this is actually a finite duration signal that you can understand, because the duration is fixed. For after some time it won't exist, so it is a finite duration signal. So how we can calculate? See, for calculating energy or power signal, first we need to see, power is equal to, if we say resistor is there and current is flowing, so we can calculate power is equal to I square R. Okay, R, or it may be if voltage is there, so P is equal to, we can say V square by R. Okay, V is there. So ultimately if R is constant, so ultimately power is directly proportional to square of this function. So we can say that if we need to calculate our energy is nothing but change in power with respect to time. So if you want to calculate power, okay, power means if you want to calculate, so you can calculate E into dt. Okay, sorry, I think I'm doing some mistake. Okay, okay, fine. It is not like this, it is like this. Power is equal to dE by dt. So you can calculate energy is equal to integration of power into dt. So if you can take minus infinite to infinite, it will be same. So energy is equal to itna, this much. Okay, so now energy will be equal to minus infinite to infinite, and power is almost, you have calculated, it is a equal to function square. So you can do it like this: f square ft square dt. So this is the relation, or this is the formula by which you can calculate if signal is energy signal. You can calculate it by using this formula. So let's do it for this question only. So the formula which we have seen, E is equal to minus infinite to infinite f square t dt. So you know ft was e to the power minus at ut. Okay, so you can write it down as minus infinite to infinite e to the power minus at ut square dt. So see, signal, any signal when multiplied by ut, you can understand that it will exist only after t is equal to 0. Any signal e to the minus at into, if you do ut, so it won't exist before t is equal to 0. It will exist after t is equal to 0 only. So you can also write it down as 0 to infinite e to the power minus at square dt. So ut is nothing but 1 only, multiple of 1 only. So here we can do is e to 0 to infinite e to the power minus 2at dt, and then you can calculate it as e to the power minus 2at is e to the power minus 2at by minus 2a, and differentiation integration 0 to infinite. So you can see minus 1 by 2a is there, and e to the power minus infinite is e to the power infinite is infinite, e to the power minus infinite is 0, and e to the power 0 is 1. So you can write it down as like this, and this will come here plus, so plus 1 by 2a. This is in joule. So now what you understood is, you have been given one signal, that is e to the power minus at ut, and you have calculated its energy. First you have calculated energy and you got some energy. That means this signal is having some finite energy in it. So energy is finite, so you can understand as this signal is energy signal. Okay, so okay, fine. Next I will ask you one more question. One more question we will take. Let's suppose this signal is there, and this is your DC signal. Let's suppose 5 values there. Okay, I think okay, it's written like this. This signal is 5. So now you need to calculate, it's going on and it's going on. Now you need to calculate it is a energy signal or power signal, and what is its energy. Okay, whatever it may be, so we need to calculate. So let's see. Okay, energy formula minus infinite to infinite our ft square dt. This was the formula. So E is equal to minus infinite to infinite will take, because the values are from minus infinite to infinite, and constant values there 5, and we need to do square and dt. So you will get 25 into t, and then it will get infinite, that is infinite. So you came to know that this signal has energy infinite. Now if the value comes infinite, now you need to calculate power. We need to calculate power, because see, this signal is energy is infinite, means it is not an energy signal, that is sure, that is of sure. So how will calculate it? So see, you know that average power is equal to your total energy by total time. This you can understand as, okay, so power will be equal to, let's suppose, E by T. Okay, so whenever your time is finite and your energy is also finite, so the value will come, something value will come. Okay, but if your time is infinite, this value, your time is infinite, like this value, the signal was like this, time was infinite, है ना? So obviously power will be, obviously it will be 0, but this value, if it is finite, then power will be 0. Now I think you can understand as, see, this is formula you know from childhood. Power is equal to energy by time. Okay, no problem. I am telling you कि if your time is infinite and energy is finite, your power will be equal to 0 only, because earlier we used to take some values like see, this was value we have taken till time infinite, but does this value exist till infinite? It was decaying. At some time it is coming 0. So after, if you take till infinite also, the value will come this much only, up till this time only. So that only I'm telling. If you take time infinite also, but some finite value is coming, it means for that power will be 0, which I have told earlier only, that for energy signal, energy will be finite but power will be 0. So this is actually proving that thing only. Now again we'll see power is equal to E by T is there, and now we'll see if time is infinite, okay, and energy is also infinite, which we have faced just now. For this signal, time was infinite and energy was also coming infinite, then this infinite by infinite, it is indeterminable. Okay, it cannot be determined, so we need to apply some mathematics, and now see what we'll do, we'll apply some average value. So power we can calculate by this formula. Power will be, see, first of all, power will be what, power, if you know it is E into dt. Okay, this you can understand it as power is equal to, sorry, I am E is equal to P into dt. So power is equal to 1 by C. Now E is equal to P into dt, you know very well. Okay, so what we'll do is we'll differentiate it, and then we'll integrate it, and then we'll divide by time period. Okay, so see what I was telling, actually slip of tongue was coming. So see, P is equal to E by T is there, P is equal to E by T, no problem is there. So what we'll do, energy you already know, energy formula you already know, and 1 by T is there. So let's do it. See, power will be equal to energy, so minus infinite to infinite, energy term was there, that is F square T dt. Earlier you used to know this, and we have to do 1 by time also for power, hai na? So 1 by time also will be for power, and for finite value of power we need to do limit t tending to infinite. So actually what we are doing, for t tending to infinite only we are taking the power, and this is the average power value which we need to calculate. So final conclusion is that for finite energy, okay, for finite energy, power will be equal to 0. See, for energy, when energy was coming finite value, power was coming 0 value. Okay, so for energy infinite, when energy became infinite value, like in this case, this case, energy was coming infinite value, then only you need to use this formula. So this formula is the second formula. First formula is only E is equal to minus infinite to infinite f square t dt. This formula only you know, and this formula first you need to calculate. If it is coming finite, then good. Otherwise, if it is coming infinite, then you need to go for this formula, okay, for checking power, it is power or not. So let's see, our signal was there, this signal was there, let's suppose 5 values there, and it was going on from this to this time, and we already calculated its energy, which came as infinite. So let's check its power. Power will be limit t tending to infinite 1 by time period, and this will be equal to minus of infinite to infinite, or minus, I think here we'll take a value which is because this signal is going on, so it is almost same, so we can take it as from minus t by 2 to t by 2 also. So here we'll take it as see, average power we need to calculate. So what we can do is, here from minus infinite to infinite, we can write minus t by 2 to t by 2, because see, if we integrate from minus t by 2 to t by 2 one complete time period and will divide by a complete, so we'll get average power, है ना? So for that purpose only we are doing. So minus we'll take here it as minus t by 2 to t by 2, and we'll take as 5 cos square dt. Okay, so now what we'll get, limit t tending to infinite, 1 by t will be there, it will be 25 into almost when it will integrate, it will come like this t, and then you'll get tt cancel, so it won't bother much. So final value will be 25 watt. So final, see, this signal was there, its in energy was coming infinite, but power is coming finite, that is average power. Okay, this is the average power. Why we are telling you it as average power? Because we are we are taking from minus t by 2 t by 2 and we are doing 1 by t, so it is a average power. Okay, so finally you can get it as this much. Okay, power can also be calculated from mean square value also. See, if sinusoidal signal is there, like this signal is there, or cosine signal, any signal is there, so power, if you want to calculate power, you can calculate directly as, if you know RMS value of that signal, RMS value, you can do squaring of that. Okay, RMS value of your signal, if you know, you can do square, or if you know effective value, you can do that square also, or you can do mean square value of ft also, you can get it. So power can be calculated for sinusoidal signal like this also, no problem. So see, now we can draw some conclusions. Okay, so we can draw some conclusion. First conclusion what we can draw is, for finite energy signal, our power will be equal to 0. Definitely power will be equal to 0. For infinite energy signal, power will be equal to, not equal to 0, it will be some finite value, it will be there. Okay, and this value is only called as this signal is only called as energy signal, and this signal will be called as power signal. Okay, and I told you which is not having infinite energy and infinite power, so it will be neither energy nor power signal, that I have told you. See, what happens is, this will, I will tell you, generally what happens, all periodic signal are by default, when you will check it, you will see all periodic signal are by default power signals, and all aperiodic signal are energy signals. See, so what happens, you can check it also, any periodic signal or any aperiodic signal, you can see. So what is happening actually, signal having finite duration. Okay, now I'm telling you, signal having finite duration. I mean to say, when we take it in time domain, there is some fixed duration. After that value should be equal to 0. There should be some fixed duration. So signals having finite duration, okay, and finite amplitude. Now finite amplitude, what does I say? Amplitude axis, there should be some finite value. This should not happen like this. This signal is going on like this, we don't know till when it is going, but it is going for amplitude also and for time also. So signal having finite duration and finite amplitude, or signal having infinite duration, okay, infinite duration, and amplitude is tending to 0. Means, see, this signal was there, this is going on, and this is going on. So for t is equal to some value, it is going on, but ultimately for t some value, it is tending to 0. This value is tending to 0. So what I am telling, signal having infinite duration but amplitude is tending to 0 are by default energy signals. Okay, simple concept. And if a signal is power signal, if signal has to be power signal, it should have infinite duration, and the values are tending to zero. The and the signal which is having infinite duration. Okay, infinite duration means I am telling you again and again, I am telling you, for time axis infinite duration is there, and the amplitude, both you should remember, the amplitude is not equal to zero. Okay, it is not tending to zero, it is some value, constant value is there, some value is there. So these signals can be termed as power signals. And third and last portion, if signal is having infinite duration and the amplitude is also tending to infinite, then this signal will be equal to neither energy nor power signal. Okay, so these all are the conditions of energy signal and power signal. Okay, I think you must have understood the proper conditions. On what condition we can say that it is an energy signal or power signal? Very easy and very effective for solving questions. You can solve by seeing also. You can solve, or you need to calculate also. See, if I say you like this, one question is there, and if I tell you it is energy signal or power signal, definitely you can, by seeing only you can say that, sir, it is a finite duration. First of all, it is a finite duration, and finite amplitude is also there, so it is definitely energy signal, definitely energy signal is there. Okay, but if I say you like this signal is there, okay, this signal is there, it is a finite duration? No sir, it is a infinite duration signal. And amplitude, what about amplitude? So sir, it is a some constant value, plus minus 1, it's varying, so it is not equal to infinite. Amplitude is some value not equal to 0, so it will be equal to power signal. And third, if I tell you like this signal is there, and then I'll tell you, sir, it is a infinite duration signal and infinite amplitude signal, so it is not a energy signal, not a power signal. Very easy concept, you can understand. So acha, whenever we perform some time shifting and all operations, scaling operations, reversal operation, what happens to energy? Actually, see, one ft is there, and if we perform all operation, let's suppose our operation is f of minus 80 plus b is there. Okay, so now if I ask you, what if this signal has some energy, let's suppose E1 energy is there, so what this signal will have energy. Okay, so see, let's suppose how we can do it. Now, as you know earlier, whenever we do some operations, like see, first always we'll do shifting operation, so t plus b will do. See, okay, so what will happen? ft was there, ft will be shifted, where it will shifted advanced mode. Okay, so let's suppose this signal was there, okay, minus 1 to 1, and now you have shifted to ft plus b, some ft plus 1 value is there. Okay, so what will happen? It will come like this only, this, okay, minus 2 and 0. Now this happens, but energy, it will it change? No, it won't change energy. Okay, energy will not change because the values are only shifted, it is not compressed or expanded. So now what we'll do f of t plus b we have done. Now we can do either scaling or reversal. So let's do reversal, scaling. So first we'll do f80 plus b, so here b will take, let's suppose we'll do f2t plus 1. Okay, so now what will happen? I'll do it here, f2t plus 1. So earlier f2t ft plus 1 was there, just we need to divide by 2 by 2, so it will come like this, minus 1 to 0. Same, something happened. Actually this signal has been compressed. Now if you take the area, you'll get less area. Okay, just half area you'll get because it has been compressed. Amplitude is same, but area will be changed. So now something has happened, and if you do minus 2t plus 1, so it will be only time scale, time reverse, so it will occur from 0 to 1. So ultimately in all three operations only the scaling operation affects energy of a signal. So if this signal ft was having energy equal to E, then f of minus at plus b will be having energy equal to E by a. Okay, this is reduced actually. So whatever scaling factor will be there, that will be there. So it has been reduced. So this value you need to remember, because this question was also asked sometime. So E by a you need to remember. Okay. Okay, now we'll take, see, we are talking about energy and power signal. So we should talk also about, now we have seen real valued signal. We should talk about complex valued signal and discrete time signal. These three things: continuous time signal, discrete time signal, and complex valued signal. For three, we are seeing every aspect. So for complex valued signal, what we can do? So complex valued signal. Okay, so complex valued signal, if you remember, so first we will take Euler signal. From Euler signal only we can see all the things. So e to the power j omega naught t, it is cos omega naught t plus j sine omega naught t. This is Euler signal. Okay, now what we need to see, this signal, you know now, this signal is periodic signal, because we have earlier in last lecture we have seen it. So e to the j omega naught t is complex valued signal, and it is a power signal. It is a periodic signal. So by default periodic signal will be power signal. Okay. Okay, so now let's see, whenever we will see complex valued signal, we should not focus on its phase part, we should only focus on its amplitude part. And the same way we can calculate energy and power. Energy will be equal to, see, minus infinite to infinite. Earlier we used to do f square t dt, है ना? This used to do, but for complex valued signal we'll do like this. Okay, mod will take f of t is given, we need to calculate its mod, and then we need to do its square. Okay, this is the energy signal. And for power also we need to do limit t tending to infinite. Limit t tending to infinite is there, 1 by time period will be always there, minus t by 2 to t by 2 it will be there, and then your ft will be there, mod part, and this is square part. Okay, so for complex valued signal you can calculate your energy and power by this formula. Obviously whichever complex signal will be there, it will have some real value and complex value. You can do mod, you can take its mod magnitude, and then you just need to do square. Simple, it is very simple concept. But how can we do it for discrete time signal? Okay, so let's see, for discrete time signal also we'll do for discrete time signal also. Okay, for discrete time signal what we'll do, again we need to calculate energy and power, and discrete time signals are there. So energy will be equal to, see, in continuous time we'll do integration, for our discrete time we'll do summation. So summation will be there. Okay, n will be equal to minus, not infinite to infinite, it will be minus n to n. Okay, for number of samples, from where minus n to plus n. Okay, and fn will be there, and you can do square if it is continuous, it is normal real valued signal, or if it is a complex valued signal you can do squaring part like this. Okay, so like this you can do. Now if you need to calculate power, so power will be calculated by limit first, where there was t tending to infinite, here it will be n tending to infinite value, है ना? And 1 by time period was there, 1 by time period. Actually in discrete time signal what will happen, see, whenever we'll take continuous time signal, what will happen, we'll take from minus t by 2 to t by 2, so that symmetry should be there, and we can check its periodicity also. For discrete time signal, see, here some values are there, here some values are there. Okay, let's suppose minus n to n values we will take. So minus n to n we are taking, but 0 at 0 also some values are there. So what we need to do, see, minus n here n values are there, here 0 to n values are there, means total 2n values are there, and plus 1 at 0 value. So what will do, 2n plus 1 will do, and summation will be there, n is equal to minus n to n. Okay, and same thing, fn will be there. If it is real valued, you can do square, otherwise if it's complex valued, you can do like this, square. So this is the formula for energy signal and power signal. You can calculate for any of the questions. If I'll take questions, it will take very much time. So for dealing questions only, we'll take some other lectures, and for question solving only, we'll perform it by using these concepts. So this is our energy and power signal. See, one example, good example I'll take, one question I'll take. Question is there, fn is there, and it is u of n. Okay, fn is there, and you have been given fn is equal to u of n. Just you need to check it is energy signal, power signal, or not, neither energy nor power, what it is. So u of n, if you plot it, you will see u of n will be like this, like this, like this, like this, and it will go on. N is equal to 0, it will start and it will go on. This is un signal. Okay, now if you see our concept, you'll see it is tending to infinite, means our duration is infinite, duration signal is there. Okay, infinite duration. Amplitude is finite amplitude. So infinite duration and finite amplitude, it will be, obviously it will come as power signal. But let's check it is a power signal or energy signal. So if it is infinite duration and if value is not tending to 0, definitely it is not an energy signal, that is sure, 100% sure. But we need to calculate power. If it is power is also infinite, it's coming, then we need to conclude that it is neither energy nor power. So first we will calculate power. Power is nothing but, for discrete time signal, power is nothing but limit n tending to infinite 1 by 2n plus 1 and summation of n is equal to minus n to n, and fn was there. Fn is nothing but your value is there 1. Okay, so fn is nothing but, actually we'll write here un, and we'll take mod and square. Okay, so now what we'll do, it can be written as limit n tending to infinite 1 by 2n plus 1 is there, and summation of, see, un will be there, means it will start from n is equal to 0 and it will go on. So we can write it as n is equal to 0 to n, and 1 value is there. Okay, so definitely we can write it as limit n tending to infinite, and summation of 1 from 0 to n, it will come as n plus 1, and it will come as 2n plus 1. So we can also write it down as limit n tending to infinite, it will be 1 plus 1 by n and 2 plus 1 by n. Like this we can write it. So whenever you write n tending to infinite, you will come as 1 by 2. So for u of n, power will be equal to half. It is a finite power, so it is a power signal. So definitely you can say it as a finite, it is a power signal. And what is power? Power is half watt. So like this you can calculate. Acha, one more thing I need to tell you, that whenever your signal is periodic, ft is periodic, then you can definitely calculate your power, because see, if signal is periodic, that means it is not an energy signal. So power, if it is periodic, so you need to calculate power. So for periodic signal, we should not go limit t tending to infinite. So because if you calculate for one period, it is same for other period also, hai na? So what we can do, limit t tending to infinite, it is gone, 1 by t definitely, and minus t by 2 to t by 2 f square t dt. This also you can write it down like this, and for discrete time signal also you can write it down like 1 by n, not limit n tending to infinite. You can directly tell 0 to n, summation of n is equal to 0 to n, and you n minus 1 for 1 less, and now you can tell f n square. Okay, because n is equal to 0 also value will take, so n minus 1 value came, fn square. So like this you can calculate your For periodic signal also you can calculate. Okay, so I think two signals are left, two classifications are left, and so I think random and deterministic signals are left, causal and non-causal signals are left, analog and digital signals are left. So we'll take in next lecture, because this lecture is also have completed 35 minutes, so we'll take it in next lecture. Till then, tata, bye bye, see you, have a good day. Jai Hind.